Welcome to the Winter Service Training Program for Ambrogio Robot Mowers. I'm Kathy Mosler of Paradise Robotics. Let's get started. Winter service extends the robot lifetime and prevents in-season downtime. Dealers provide a time-saving service for robot owners, as well as registration of winter service with the manufacturer for warranty purposes. If a robot is out of warranty, it is permissible for customers to do their own winter service. Customers who do not have a dealer should contact Paradise Robotics for assistance. Battery lifetime for Ambrogio robots is typically 8 to 10 years, but only if the winter charging rules are followed. Just before taking the robot out of service, give it a full charge. Then perform winter service activities and tests. Charge the robot one more time using the base or the winter charging cable. Rather than leaving the robot on the charger the entire winter, charge the robot once per month. The winter charging cable has a current limit of 5 amps, but some robots come with a power supply that is greater than 5 amps. For these models, it is necessary to purchase a 2 amp charger or charge the robot in the base if the base has been brought indoors. Robots should never be charged outdoors if the temperature has fallen below freezing, that is, 32 degrees Fahrenheit or 0 degrees Celsius. The longest a robot can sit uncharged without reducing warranty coverage is 5 consecutive months. Exposed metal contacts always collect invisible oxidation over time. The oxidation must be cleaned each year to prevent charging and rain sensing issues. When the oxidation is allowed to accumulate, a faulty conclusion that the battery has failed can be the result. Always inquire about the age of the battery because charging issues are typically due to this oxidation problem or something else, such as a bad connection in the base, whenever the battery is less than 8 years old. Preventing the unnecessary sale of batteries has 2 advantages. First, it increases customer satisfaction and loyalty, which leads to repeat business. Second, it is better for the environment. Clean the contacts by following the instructions on the slide. Fine sandpaper, a rust remover pad, or electronics cleaner are the best methods. Clean the posts under the recharging nuts for models that have them. If necessary, scrub the posts until they are shiny and verify there is good contact with an ohm meter. It is typical for a robot to have a significant amount of grass that clogs the top or underside, depending on the model. A putty knife is the best tool for scraping and removing much of the grass. A paint stick can be used to reach grass under the blade guard for models that come with one. A Small Shop Vac type of vacuum cleaner is an essential tool for performing winter service. By vacuuming as you scrape grass, the overall mess can be reduced significantly. Clean outer surfaces with a damp but not dripping cloth. Use a soft toothbrush to get into tight spaces. If you decide to use a cleaning agent, choose something mild such as well-diluted Dawn dish soap. Use a tool such as a flathead screwdriver to lift the front cover off. It is held on with Velcro. Once the cover is removed, place it in water to soak. Do not soak it overnight as it may cause the labels to come off. Vacuum the top first, then wipe it with a damp cloth. There are 2 levels of cleaning in winter service, functional and detailing. A functional cleaning can be vacuuming and using a dry brush to brush out the remaining debris. Detailing can be wiping and removing all grass stains. Landscapers that maintain an entire fleet of robots may choose to only do a functional cleaning to save time. Dealers may choose to offer 2 levels of winter service, such as basic and full detailing. Basic winter service would be functional and is at the level the manufacturer requires to maintain the warranty, while full detailing is as close to perfection as the dealer desires. The front undercover has about 10 recessed screws. If dirt and debris are allowed to accumulate, it can create difficulties to remove the undercover during a future repair. Remove or loosen debris with a small needle nose plier or flathead screwdriver. Vacuum and then clean stubborn dirt with a wet Q-tip. The goal is to ensure the screw heads are not clogged with dirt and remain functional. Depending on the level of cleaning being performed, that is, functional or detailing, the dirt around the edges can be cleaned with a wet toothbrush and then wiped, or it can be left as is. The undercover will be removed in a future step. After reassembly, plan to insert cotton balls in each hole to avoid the screw hole cleaning step during future winter service. Remove and soak the blade in water. We find that a nut driver is easier than using a Phillips head screwdriver to remove the blade. After soaking, scrape the blade with a putty knife and sharpen it with a Dremel tool that has a sanding bit, or do it another way. Use a technique similar to sharpening a kitchen knife. A functional cleaning of the underside is to scrape off major debris with a putty knife. To fully detail the underside, the robot can be turned upside down and a damp but not dripping cloth can be laid on top of stubborn stains for about 30 minutes. Brush the softened grass with a small nylon scrub brush and wipe it off and repeat as needed until fully cleaned. Never ever use a power washer or hose to clean the underside. There are electronics up above the wheels and there is a risk of water seeping into the blade motor. Water will cause electrical shorts that will make the electronics fail. Winter service is the time to discover and resolve unusual issues. Inspect the robot and try to identify problems such as the magnets missing from the display cover, top cover Velcro issues, or as shown, a bent front wheel frame. E6000 glue, which is widely available online and at major retailers, is an essential material for repairing unusual problems. Choose the version that dries clear. It is durable, flexible, long-lasting, and highly water-resistant. We have used it for sealing possible water leaks. Components that turn have a high risk of picking up debris. The debris winds itself around wheel axles and on rare occasions, the blade motor shaft. This debris must be removed. It creates friction that can reduce the runtime or worse, cause a failure if left in place year after year. A small needle nose pliers is often helpful for grabbing onto debris. After cleaning the debris, ensure the tire turns 360 degrees. Then also verify that the wheel assembly turns cleanly 360 degrees on its vertical axis. Do not apply grease to any front wheel joints. Certain models have a motorized height adjustment. These models have a rubber bellows that expands and contracts when the height is changed. It is important to clean the grass between each bellows fold. Also inspect the bellows for damage and replace it if necessary. Batteries and power modules for models that have the battery installed from the outside of the robot, such as 4.0 and 4.36, need to have their contacts inspected. This step is not necessary for models that have their batteries internally installed. Use a T20 screwdriver of high quality and in good condition to avoid stripping the screw heads. A stripped head on these components is seriously detrimental to the ability to troubleshoot and repair certain power-related problems. Always provide a firm grip and turn slowly by hand. Never use a power tool due to the risk of stripping screws. When reassembling these screws, do not apply thread locks since this could create difficulty in removing them in the future. Contact us if you encounter a stripped screw and are unable to remove it. We will provide some tips. Contacts on both sides must be checked. Look at the pins on the robot side and identify pins that have sunk down. If pins are not at the same heights, the connector has failed and it must be replaced. Then check the contacts on the battery and power module sides. Melted pins on the battery side are an indication that the battery should be replaced. Melted pins on the power module may not require the module to be replaced if the damage is not too severe. This battery connector issue occurs most often in robots manufactured 2019 and before. There was a factory quality issue that introduced a weak connection. Typically, premium or extra premium models are at higher risk, especially if an installation error is present that causes a false rapid return detection. A false rapid return causes the robot to circle, resulting in a very low battery. During recharge, the very low battery draws the most current and creates the highest failure risk. All robots manufactured 2019 and earlier must be inspected for these issues. To reduce workload and to eliminate the risk of stripping screw heads, dealers may use their judgment regarding performing this inspection step on robots manufactured 2020 and later. Rear wheels with compacted debris must be completely disassembled for cleaning. Use a high-quality metric hex Allen wrench to remove the wheel bolt. It will take significant force to turn it due to the presence of thread lock. Provide even pressure and use the Allen wrench's long side to gain leverage. If detailing, use the correct size Torx screwdriver to remove the fender if present. For a functional cleaning, it may not be necessary to remove the fender. Simply brush grass and debris off with a stiff nylon brush. Scrape any mud that might be visible after removing the wheel. Remove large debris from wheels and then soak the wheel parts and fender in water to accelerate cleaning. Clean the old grease off of the hexagon and the wheel with a paper towel. Inspect the wheel motor shaft for wound hair or other debris. Remove it if found. Upon reassembly, a thin layer of Lucas oil red grease with anti-seize will be used to keep the wheel from seizing onto the hexagon, which is a major issue. Find Lucas oil red grease at auto parts stores. If you can't find it, use an appropriate equivalent. Do not substitute a different grease type. To find an equivalent grease, use the material safety datasheet of Lucas oil red grease to identify the ingredients. The material safety datasheet of Lucas oil red grease is easily found with Google. A critical step is to verify the integrity of thread lock that is present on wheel motor mounting screws. The test is important because when there is no thread lock on the screws, they can vibrate out. The wheel will go out of balance and will cause catastrophic failures, such as a failure of the wheel motor, a broken chassis, or in worst case scenarios, a failure of the wheel motor driver on the motherboard. The test is easily performed by attempting to gently turn the screw. If thread lock is worn out or not present, the screw will turn immediately with little or no resistance. There are two additional important screws to check. One is a tiny screw that goes through the center of the hexagon and the motor shaft, and the other is a set screw on the side of the hexagon. Both of these screws are metric hex screws. There is no need to loosen the screws if thread lock is in good condition. It is important to use the right type of thread lock. The thread lock recommended by the manufacturer is not easy to obtain in the US. We have substituted green Loctite or Permatex that is available at auto parts stores. It is important to avoid using too much thread lock or a thread lock that is too strong, such as blue. It is also important not to tighten the screws too much. I like to use the phrase girl tight, which means don't flex your muscles. Next, apply a thin layer of red grease onto each hexagon face as described previously. Finish cleaning the wheels and dry the inside of the rubber tires if they had been soaked. Then assemble the tires onto the rims. The rims with tires attached are labeled A and B. Assemble the wheels as shown, following the 6 steps. First install the plate C. Stack C with A. Then stack B with A. Add the outer ring in the final step. When inserting each screw, turn left first until you hear a click. Then turn the screw right. If you feel resistance, likely the screw has been cross-threaded. Stop immediately and try again. Make all screws girl tight. Repeat on each layer until all screws are installed. Do not use thread lock on the wheel screws. Later, the wheel will be assembled to the wheel motor shaft. After installing the wheel bolt, remember to snap on the hubcap. Clean the bump sensor bellows at the front of the robot by loosening grass with a tool and vacuuming. Verify the plastic water seal is present and in good condition. Replace it if it is missing or broken. Wipe the bellows with water. An optional step for longer lifetime of rubber components is to apply Armor All UV protectant. It can be used on clean tires and the outer covers too. Remove each cover using the appropriate size Torx screwdriver. Remove the grass and dirt that has accumulated around the edges with a slightly damp cloth. Make sure the cloth is not dripping wet since water could get into the exposed electronics. Look at the display film on the rear cover and ensure it is not coming off. Repair it if necessary. Do not let glue bleed onto the film when repairing. Use enough to seal the water out, but not so much as it oozes into the visible area. Use E6000 glue for the repair. Check the seal of the A logo. Robots manufactured 2019 and earlier may need to have their seals refreshed with E6000 glue. Apply a thin continuous layer. If the glue bleeds into the transparent areas of the A logo, it will be visible from the top. It is easy to clean the joint when the top cover is off. Loosen the grass with a tool and vacuum. The bottom side of the joint can be cleaned in a similar manner while cleaning the underside. Then check the joint for mechanical integrity by rotating the deck. If it feels loose, inspect for the cause of the issue and perform the repair. Clean the seals with a damp cloth. Glue loose seals with E6000 glue. Decaying grass creates humidity, which is bad for electronics. Vacuum both inner cavities. Reassemble the covers. Another important test is to look for play in the wheel motor. This can be done before or after cleaning. When doing it after cleaning, perform the test before installing the wheel bolt. Try to move the wheel from side to side. If it moves a significant amount, there may be a problem with the wheel motor shaft parts or the wheel motor itself. Investigate and solve the problem. Use blue thread lock, only 1 or 2 drops. Apply it a few threads up from the bottom of the bolt. Install the battery. Do not use thread lock on battery screws. Armor All Protectant can be applied to rubber components to extend their lifetimes. It brings back shine too. This step is not required, but is recommended. Prior to applying Armor All or spray wax to outer covers, clean the surfaces with water. The robots in the photo were in operation for 1 season. These products restore their original appearance. L250i and 350i models have only a few differences compared to next line models. The winter service goals are the same: cleaning, mechanical checks, and electrical checks. The 250i and 350i hubcaps do not come out as easily as the next line models. Use a scribe, push the tab in towards the A and simultaneously lift. The tabs are located at the 3 points of the A. The bump sensors for 250i and 350i are under the top cover. The top cover is an integral part of the bumping system. The magnet that is sensed by the electronics is at the end of the metal magnet assembly. Remove the assembly and vacuum the cavity inside. Grass falls in there every season. Upon reassembly, ensure the post goes through the hole at the center of the 4 springs and make sure the cover's horizontal slots fit correctly over the metal protrusions on the magnet assembly. The internal batteries of these models do not require any checks or maintenance. The robot should be open to vacuum grass that may have gotten inside and to clean the seals of the upper and lower chassis. Bear in mind that the circuits are live since the battery is installed and connected. Be careful not to drop metal objects inside or let water drip. The top side of the chassis usually has a lot of accumulated grass. Brush or vacuum it off. If detailing, wipe with a damp cloth. As shown on the previous slide, remove the metal magnet assemblies. There are 2 magnet assemblies and 2 dummy assemblies on the 250i. The 350i has 3 magnet assemblies. Vacuum the cavities. When reassembling, look for the horizontal keys on the magnet assemblies. These keys fit through the horizontal slots on the outer cover. If the cover is not reassembled correctly, there will be bump errors. After fully assembling the robot, it is time to perform the electronics checks. All robots manufactured 2017 and later use the TXC1 transmitter. That is, dealers can use the transmitter of any robot model for these tests. Set up a loop that uses around 50 feet of wire. Typically, the tests are performed without having the robot move around in the loop. The wire can be tacked to a wall or may be laid on objects in your facility. To completely check the robot will need to be placed a few feet inside the wire and a few feet outside the wire. Dealers will perform the tests using the service menu. DIY customers will use the normal mode as if the robot is in their yard. If a DIY customer's base is permanently installed outdoors, testing may have to wait until spring in some climates. Dealers will run a robot report before starting the tests. Follow the steps on the slide, storing a week of syslog data from the last time the robot ran in a yard. Consider using the Ambrogio client for Windows PCs rather than the Ambrogio Service app for generating the robot report. Data downloads between the robot and the computer are much faster. It is easy to generate a PDF of the robot report that may need to be sent to the factory for certain assistance requests. Now perform a software update if new software is available. Then generate a second robot report. After entering the service menu, you will find several options for settings and tests. Only test sensors, test motors, and test connect are needed. Do not use auto check because it requires a special setup. Place the robot in the loop near the transmitter. Follow the instructions A through G on the slide. If the robot is too far from the transmitter, the air marker item will be dim. To confirm the item toggles and is not stuck on, move the robot away from the transmitter a sufficient distance. If the lift sensor is illuminated while the robot is on the ground, that is, not lifted, it means there's an issue and a repair is required. Move the front wheel up and down. If the associated item does not toggle, something has failed. DIY customers can run the robot in a test loop or in the yard to perform the tests. Water can be used for the rain sensor, a broomstick can be used to simulate a bump. The robot can be lifted to cause the front wheels to drop. The robot will stop with a lift error. It is a bit difficult for DIY customers to do the tilt test without the service menu. I suggest ignoring that one since tilt issues are very rare. The signal can also be tested in the Signal Settings menu. If there is no signal present in the Test Sensors menu, look at the Signal Settings menu to see if the robot is set to a different channel. Change the channel to confirm the hardware is working, then change it back. Unlike the transmitter that has its channel set with a dip switch, the channels on the robot are determined with software. Now enter the motor test from the service menu and follow the instructions on the slide. Generally, I like to run the wheel motors at full speed in each direction. The blade motor test is a simple on and off. It either works or it doesn't. The Test Connect menu item allows you to observe the strength of the cellular signal and to verify the GPS receiver picks up its signal. The GSM RSSI value should be greater than 0. If not, move the robot to a different location. Lower numbers reflect a stronger signal. If 0 dB is displayed independent of the location, it may be necessary to perform an upgrade as indicated on the slide. Testing GPS requires the robot to be located outdoors. GPS signals are blocked by buildings, so you may find it necessary to move a significant distance away. Wait at least 10 minutes before trying another location. The latitude and longitude coordinates will be displayed when the robot locks on the signal. DIY customers can simply observe the bars and the GPS icon on the display in the normal mode. This completes the electronics checks. Once each test is performed successfully, the robot will be fully functional when returned to the customer. Winter service registration is required to keep the warranty active. This is discussed on the next slide. The final step is to register winter service in the cloud. This is done by dealers using the Ambrogio Service app or the Ambrogio Service client. Winter service registration is required starting the very first year to keep warranties active. Dealers can follow the steps on the slide to register winter service. Each robot has its prior winter service record stored in the cloud. Dealers are responsible for verifying winter service was performed each year before entering any extended warranty claims. Dealers in Illinois, Indiana, Michigan, Ohio, and Wisconsin can contact us for assistance with winter service registration. Dealers in other locations should contact the regional distributor in their respective areas. Dealer locations can be found in the Ambrogio Remote app or on the Ambrogio website. Customers located in the United States who have checked the map and do not find a dealer nearby should contact us for assistance. Thank you for your participation. If you came across this video and are interested in becoming an Ambrogio dealer in the USA or Canada, contact us and you will be directed to the appropriate regional distributor in your location. Follow us on Facebook at Paradise Robotics Robot Mowers, on Instagram at Paradise Robotics, and on Twitter at Paradise Robots. You can also subscribe to my blog by Googling the Robot Ladies blog. I hope you found this video informative and useful. Comments and likes are very much appreciated.